Self-join in SQL.
Hello, in this video you will learn everything there is to know about the idea of a self-join, including what it is, why you will need it, and some examples. Let me explain if you have never heard of a self-join. The act of joining a table to itself is known as a self-join, but how do you do that? How come you would want to do that? What's the point then? Joins are used to link tables together based on shared fields. When you write queries that select data from two or more tables, you might require data from the same table more than once in certain circumstances. How come you would want to do that? Let's examine a particular instance in point. This example is called employees and managers. Let's say we have this table here called employee. Oracle SQL Server, Postgre SQL, and MySQL are just a few of the databases that can use the self-join concept and the SQL. So, we have an employee table that has an ID and a name. How do we keep track of a manager's employees? A second table called manager, where a manager may have one or more employees, could be created. The managers of those managers, though, what about them? Although we could make a separate table for each level of manager, that would make the structure less flexible and make our queries more difficult. If we give the idea of a manager some thought, we might realize that a manager is also an employee, so we can store the manager's information in the employee table alongside other employees. How do we recognize an employee's manager? We can add a new column to the table called Manager ID. This is a foreign key. The other record in the same table is referenced by it. Although it seems odd, this idea actually works. It is acceptable to use the same table as a foreign key reference. You probably don't want to refer to the same row, but you can refer to other rows in the table. As an illustration, employee ID 1 refers to employee ID 2, Michael, who is identified by the manager ID of 2. Michael can have his own manager, which is another record in the table. This is all well and good, but how does it relate to a self-join? As I mentioned earlier in this video, the act of joining a table to itself is known as a self-join. Here is an illustration of this. Let's say you wanted to list the manager's name alongside each employee's name in the table. What format would the query take? We can choose from the employee table to start. Both the employee ID and the name are selectable. The end result will resemble this. How about their manager? Since we are aware of the manager ID, we can include it in our select clause. These are the outcomes. However, we need to know the manager's name. How can we achieve that? In actuality, the manager has a different employee record. If these were in two tables, a join clause would be added to accomplish this, specifying the common fields and adding the second table. The same process is used for a self-join. The employee table is also the other table to which the query is joined when we add an inner join. Here the same table has been specified twice. Now that the columns have been specified, we can make sure that the manager ID in one row matches the employee ID in another. We say that on employee.manager.id is equal to employee.id. However, if we include this, the database won't understand what we mean. Despite adding the employee table twice, we are still not going to get the desired outcomes. How do we tell the join clause which table we want? We add aliases for tables. One employee table can be designated as the employee and the other employee table can be designated as the manager. This can be accomplished by following the first employee table with an E or another short name. After the second table, a M follows. Employee is represented by the letter E and manager is represented by the letter M. To indicate that this is an alias, we can use the word as in this sentence. It's optional, and when it comes to table aliases, personal preference usually rules. Now that we have clarified our criteria, we can say in the join clause that an e-manager ID equals m.employee ID. This should make things clearer. The employee's manager ID and the manager's employee ID should match. The table aliases can then be added to the selected clause after being added to the table. Before each column, enter a E here. Now that we have the letter E before each column, we know the information belongs to the employee. How about the name of the manager? We have a manager representing alias of M in the employee table. By adding a column to the select clause that begins with the table alias M and ends with a name like imp name, we can display the manager's name. The manager for that employee's name should appear here. Let's now execute the query. The outcomes are displayed here. Each employee's name, ID, and title are all visible, as well as the manager's name and ID. This is accomplished through the use of a self-join, which entails adding the same table to the query twice and giving each one a different alias. Two columns have the name emp name because that is what the table calls them. The output of this is a little unclear. By using a common alias, we can alter the name of the column in the output. Let's give the name field, which is taken from the manager record, a column alias for the manager name. In order to do this, we first specify AS and then the manager's name. Again, the AS keyword is not required, but in my opinion, it should be added to column aliases so that it is obvious that an alias is being used and that you have not simply forgotten to use a comma or something. Here are the outcomes. After those modifications, we can see that the output now includes a manager name column, which helps to make it a little clearer. In an entity relationship diagram, the table would appear as shown. There is a relationship line that joins to itself, as can be seen. We can see on the diagram that a self-join is possible in this way. Product categories are yet another frequent illustration of how self-joins can be used. Products are frequently categorized on e-commerce sites like Amazon. Subcategories within these categories may be found at various levels. We can have a single table that stores categories instead of 3, 4 or 10 different tables. So that we know which category each row belongs to, we can then have an ID in the table that refers to the parent category ID. By reducing repetition in our database tables, making our queries simpler and making our data easier to understand, we can enable developers to use a self-join. One last point to make is that we used an inner join in our previous query. This will combine all records where both sides have a match. However, occasionally a record won't have a corresponding record in the table. If the employee is the CEO, manager ID may have a null value. If a category is the top level category, the parent category ID may have a null value.
These top level rows won't be displayed in the event that you use an inner join.
We must use an outer join in order to display these rows. Depending on how the query is put together, we can employ either a left or a right outer join. In this example, we can use employee left join manager to see all of the employees and their managers, even if some employees like Clary don't have managers. This indicates that all employees are displayed along with either their manager or a null value. Here are the outcomes of this left join query. It is possible to notice a small difference, but that is due to use of an outer join, which can be either a left or a right outer join. We have now reached the conclusion of this video on the self-join idea.
Thank you.
So guys, this was for today. Give us your thoughts on this in the comment section, and if you appreciate our content, please hit the like button and subscribe to our channel. Share this video with your family and friends. We will meet you soon in the next video. Thank you. Jai Hind.